Hello everybody, we are going to solve the sixth Leetcode problem today. It's called Zig Zag Conversion. It has a difficulty of medium. Basically, what Zig Zag Conversion means is that if we have the string PayPal is hiring, don't know why that's there, then we put it in a zigzag pattern. It took me a second to figure out, but basically it goes down and then it's zagging upwards diagonally. So PayPal is hiring. So it's like moving in a zigzag pattern. It's easier to understand when there's 4 rows instead of 3. But basically, once you have this pattern laid out, what it wants as a return value is reading in the string line by line from left to right. So it goes from PayPal is hiring to this string here, starting at the first row and then going to the second row, going to the third row. So we're writing that function. The examples here are more clear. So here's this other example. You can see the zigzag pattern a little bit better. So it goes down and then it comes diagonally back up, down, diagonally back up, and down. And so I've thought about this for a little bit, and I already kind of think I have an approach on how to solve it. And basically, what we're going to try to do, if I can explain it beforehand, is we're going to have a few variables. One is going to represent our x coordinate, and that is what column we're in. Basically, we're going to have a y coordinate that's going to represent the row. We're going to have our rows, and that's where we're going to store each character so that we have an output value at the end. And then we also need a Boolean, I want to say, to know whether we're zigging or we're zagging. And that's exactly what I'm going to call it. Basically, we're either going, there's 2 states that we can be in, and those are either going straight down the column or we're going diagonally back upwards towards the top, towards the first row. So if we're zigging, I'm going to say if we're zigging, we're going straight down, and if we're zagging, we're going diagonally back up. So let's get those variables out there and then get started. Oh, and for like time complexity, this is just requires a single loop through the string, so that's all good. And memory is just these variables that we have, so we don't even have any additional memory storage other than the string itself. So let's jump into it. So what did I say? We need an x coordinate, which I almost typed const, and that would have been silly. So we're going to say let x is 0, let y is 0, let is zigging is going to be true because we start out by going straight down. And like I said, zigging is when we're going straight down. And then the last one is our rows, which could be a const, and that's going to be the empty array. And at the end, this rows is going to have nested arrays, and it's going to have as many nested arrays as are the numRows parameter. So, excuse me, we need a for loop, and that's going to be over the index of each character in the string. So let I equals 0, I is less than s dot length, I plus plus, and then basically we zig until our we zig until our y coordinate is equal to the number of rows, or maybe one less because we're 0 indexed. So our first loop through, we're going to place p in the first row, a in the second row, y in the third row, and p in the fourth row. And then our I coordinate is going to be 0, 1, 2, 3, which is actually going to be 1 less than numRows. So that's our comparison. As soon as we hit the length of rows, then we switch our Boolean of a zigging. We're going to say false. Now we're zagging back upwards. And then that's going to determine how we place our characters. And I want to say, actually, I want to initialize these rows with as many entries as there are numRows, because I don't want to have to initialize a new array every time we get to a new row. So let's see. I want to say new array of numRows, and then we're going to map that, and for each entry, we're just going to initialize a new empty array. And then we're going to prepend on that array every time we add to a row. prepend? No. We're not going to prepend. We're going to append. We're going to push onto the array. Okay. So we start off by zigging, and for each, so we have to actually know whether we're zigging or zagging to determine what to do with our character. Let's get our character first. So our char at the current position is going to be s of I, and then how do we want to handle this? If we are zigging, then we want to place the, how is this going to work? We start at 0, 0, and we want to do something at 0, 0, which is place the letter P, for this example, in the first row. Maybe we'll just code it up and see how that goes. So for here, we want to say rows of y, because this is going to be our 0th row, which is going to be an empty array right now. We want to push our character onto it. And then we want to allow the loop to continue. Let's just say that we're always going to be zigging for now, just so we can continue this and not worry about zagging. So we push that. Oh, okay. So what we need to do if we're zigging, so this is what, this is how you determine, or like what's different between zigging and zagging, is how we change x and y. So if we're zigging, we go ahead and push my character onto the row, and then we increase our y by 1. I'm going to do y++, even though I swore off the post increment operator a few videos ago. So that's going to increase y by 1, and then at some point we need to check if our y is equal to num rows. So maybe let's go ahead and do some nested ifs, and then we'll maybe refactor later. So if y is equal to num rows minus 1, so if we're at the end and we're zigging, then we want to switch to zagging. So is zagging is true, and our next y should be, it should subtract instead of add. So actually, let's go ahead and make this a block. We'll say y minus minus, else y plus plus. Can I do that? I think I can do that. Whoops, and we're going to leave it. So if we're zigging and we've hit the end, then we switch to zagging and we subtract y by 1. As well, we need to increase x by 1. And then our next loop will handle placing this correctly. And if we have not switched to zagging, then we just continue increasing our y, what's our y coordinate, by 1. Perfect. And then, let's see. And then our loop continues, and I think that's all good. Actually, we don't need, we can put this outside of the if statement, because I think we're always going to do this. Yeah, I think we're always going to do that. And then, so that's really, wait a second. Yeah, okay, this is 2 statements. We're going to refactor this. I don't really like that very much, but that's okay. So moving on to this else block. Now for zagging, same thing. We've already pushed the character where it needs to be. And then our next move of our x and y coordinate is we want to increase x by 1 unless we are at y equals 0. So if we just move to y equals 0, then we want to switch to zigging again. There's 3 G's there. And the other thing we want to do is not increase the x coordinate anymore and just increase the y coordinate by 1. Otherwise, we subtract y, we decrease the y coordinate because we're moving back up, and we also increase the x coordinate. There's definitely some refactoring here, and I'm going to be so excited to make it, but for now, we're going to leave this alone. So now our for loop is going to go through each character. It's going to start at P, and we're zigging, and our y is not equal to num rows minus 1, So we're just going to increase y by 1, and then we'll push rows 1 dot push character. We're just going to add the a to the second row. Perfect. Then we'll go through until y hits the end, and then we'll increase x by 1, subtract y by 1 until we're done zagging. When y hits 0, and then we say we're zigging again, y increases by 1, and x goes up by 1. Wait, I'm confused. I confused myself. Yeah, if we are zagging and we switch, we just increase y by 1, and then the next time through, we know that we're zigging, which is great. So I think that might, that gives us our rows, and we want to convert them into, let's make some space. We want to convert our rows into a string. So the way we're going to do that is with the reduce function. We love reduce functions. So return rows.reduce, and I want to say that our output is going to be a string. I want to call it string, and then each loop is going to be a row passed in. We'll say string plus row dot join, because we're going to turn our characters into a single string and then add them to the original string that we're forming in our reduce. And then we're going to start with the default value of an empty string. So the first time this reduce is called, string is going to be an empty string, and then our row is going to be the first row, p, I, n, and then we're going to join that into a string of pin, and then add it to the empty string, and that should give us our final result. I kind of want to say this is going to work, unless I messed up the syntax somewhere. Okay, awesome. So we got PAP. Output PAPLSI. So our Y does show up eventually. Our rows, we have 3 rows. So how did we get, it's really hard to map this in my head because I have no idea what's going on. I kind of want to see what the rows looked like before we got here, just to see if the reduce is wrong or is it our looping that's wrong. I want to say it's probably the looping or a for loop that's wrong, but just want to double check. Okay, so we have, oh, that is super wrong. We just have P in the first row, so what are we doing wrong here? I wish I could make this smaller and still look at the code. But basically, we never got back to y is 0. Okay, I think I know what's going on here. So when we're zagging, wait, did we zig correctly? I don't know. Let's think about this. So if our y is 0, we're actually increasing it again. But we should have gotten here at some point and pushed a new character onto y. So how did that happen? So we're initially zigging, and then we get to y is num rows minus 1, and then we switch to zagging, and oh my gosh, that's not, oh no. I knew that when you have fun with code, you eventually mess yourself up. So we want to say that we're not zigging. I said is zagging is true. We only have a single Boolean flag. It's called zigging. We are either zigging or not zigging. Let's try this again. Hey, we got it. So let's go ahead and do the full submission. And even if this works, I'm going to try to refactor, although the video might get less interesting at that point. Who knows? Cannot read property push of undefined. So is it because of there's a single row? That's why. So what do we expect to happen? We expect to see A, B as an output here too. With a single row, it should just go straight across. So how do we handle, we could just like do a check if num rows is 1 and just return the original string. But I kind of want to handle it. I think that would be nice. So what should happen? We should basically, we should never be zagging, but that's impossible because, yeah, what's gonna happen there? So what does happen? We're gonna start off by zigging, and then our y is equal to numRows minus 1, which is true, and 0 is equal to 0. Our numRows is 1. And then we're going to try to switch to not zigging anymore. Our x is going to go up by 1, which doesn't really matter. And then, wait, does our x not matter? Hold on a sec. We'll loop back to that. And then we subtract from y, which also, again, oh, I see what, so we try to subtract from y, and we'll end up with y is negative, y is a negative number, and that won't work for our rows. So what we want to do is never switch there. Boy, I would rather just kind of catch this edge case now that I think about it. So if numRows equals 1, we just return s. I hope they don't throw in 0. I don't know how that would possibly work. Oh, shoot. I didn't mean to run that, but we're going to let it go. Okay. Still working. Oh, dear. Hey, okay, great. We actually did it. Very slow. Faster than 10%. That's pretty bad. I don't know why. We do have a console log. That could make a difference. And also we're going to refactor this. If you hold on for a second. If you're happy with this code, great. You can leave the video. Otherwise, we're going to refactor. So we are at 55%. That's average. I guess I'm okay with average. But we're going to work on refactoring. So there's something I noticed is that we never actually care about x. So we're actually doing too much work here. I didn't even realize that this would happen, but it totally makes sense that we don't need x, because if we look here, our y increases and then our y decreases, but we're always appending to our rows. So it doesn't really matter unless we were trying to create this actual grid out of like a 2D space of arrays. So great, we can get rid of the x variable. We don't need it. I also thought I saw something interesting with the y variable. Well, let me just think. So with this if statement, I don't like this very much. I'm not even sure. Do we need to know if we're zigging or not? There's definitely some simplification that can be made here, and I really want to find it. We could try to flatten. So one idea is that we could flatten this if statement into like 4 different cases. But one thing that's important to notice is that we have cases where y increases, and then we have a case where y increases and a zigging becomes true. And we have 2 cases where y decreases, and one of them sets is zigging to false. Basically, if we like kind of inverted this if loop and put them, how do I say this? What am I trying to explain? There might be a better way to flatten this if loop. If loop's not a loop, this if block. I want to see if we can do the y coordinate change and the Boolean change in different if statements, I think is what I want to try. So let's try to rewrite this in place. So y increases when we are zigging and we are not at the end of the row. Or when we're done zagging, y increases. This is challenging. I don't know if this can be flattened cleverly. Or perhaps what we would need to do is push if we did our push after the if block, and after we changed the x coordinates, that might be interesting, but we would need to start our index at -1, and I don't really love that idea. I don't know. Maybe if we just rewrite it, something will come to us. When we decrease y, when we're either done zigging or the default case for zagging, but we can't just, it's like the next action is one or the other. I feel like there's something really obvious. I just don't know what it is. We can definitely handle zigging and zagging Boolean cases separately, which is really nice. So maybe we'll just try to do that. So if y, can't type. If y is equal to numRows -1, then we are always going to do this. We're always going to be done zigging. Otherwise, if y is equal to 0, then we always start zigging again. And then we don't need to do this, and we don't need to do this. And then our if block becomes just a matter of, if we set zigging and zagging beforehand, can we now use that knowledge to increase or decrease the y? I think we can. So when y hits the end, we're going to switch zigging to false, and then we say, if zigging, y should increase. If not, which we could do this in one line. It's actually, oh boy, this is a weird way to do it. And that is a ternary that just evaluates. Alternatively, maybe a cleaner way is like assigning y to this, y plus 1, else y minus 1. We'll do that because it makes more sense. I think I want to say that this is the exact same output, so let's think it through. We get to this first if statement, and okay, no, the very first loop through, we start with is zigging is true. And our y actually starts at 0. Oh yeah, that is exactly why we have to increase the y beforehand. Because at this point, we're going to immediately, oh, you know what, that's, no, this still seems wrong. The first loop through, we would switch zigging to true and then increase it. But that seems possibly problematic. Let's keep thinking it through. And then if we're zigging, y is going to increase by 1, which is what we want it to do. And then the second loop through, let's say we're on an example with numRows of 4, we neither of these are true, and then we increase y by 1 again, increase y by 1 again. So, sorry, on 0, I is 0, I is 1, I is 2, then our y is still 0, 1, 2. Our y is staying the same as our I. And then we get down here, I is now 0, 1, 2, 3. And then we are going to we're going to switch to zigging as false. But we've already pushed our character. And then we're going to switch our zigging to false. And then we're going to subtract by 1. This seems fine. Okay, and then our I increases by 1 again. And our y should go down because we are, our y has decreased by 1. Do we actually ever allow y equal to 4? I believe we do. So the first loop through, I and y are both 0. And then second loop, they're both 1, then both 2. And then 3, 0, 1. No, something's wrong. Our y starts at 0 and our I starts at 0, but our I is going to be 4 when our I is going to be 3 when our y is only 2, and it's kind of trailing, our y is trailing our I before we push it. I'm struggling here. I might need to like take a break. Okay. Our y is trailing our I when we push it. No, that's not true. I am having difficulty here because when I is 1, we do change our y to be 1. So yeah, by the time I is 3, our y is also 3. And then we push, and then we switch to zagging, or not zigging anymore, and then we decrease y by 1. I want to say this is going to work, but I could be wrong. I'm not sure I'm thinking straight, and this really shortened it a lot as well, but if it doesn't work, then it doesn't work. Okay, that works. That gives me a lot of faith. Hey, look at that. We got slightly faster too. Probably could just be the way it runs. Could be just chance. But yeah, I really like this solution. I'm glad we were able to simplify that if block. This is really nice. What else do I have to say? I don't know. I guess that's probably gonna be the end of the video. And thanks for watching. Hope you learned something. I really enjoyed it, and I'll put this code on GitHub. What else? Thanks for being here. I'll see you in the next one. Bye.